Hello to all the viewers. Today, I am showing you how to remove torsion from the building. At first, I will let you know when does torsion occur, and then I will tell how to judge that the building has torsion or not. And then the last portion will be how can we remove the torsion. Okay. At first, I have a building plan. As you can see, it is a bit irregular in shape in y direction. So it is a commercial hall. So I have modeled the building in ETABS in the similar fashion. Generally, torsional irregularity exists when the delta minimum is displacement due to lateral load, and delta max is maximum displacement due to lateral load. When delta max is greater than 1.5 times delta minimum, then it is called that the torsion irregularity exists. And now I will show you in ETABS. Okay, I have modeled the building. I have set all the necessary configuration, including all the loading. Now I am going to run this program. Okay, the building is analyzed. Now I will go to display. So tables, I will check nodal participating mass ratio, and also I will check uh, maximum story max over average displacement. Okay, I will click on OK. Now in this figure, in this building, the building is in mode 1. The building is mass is participating 17.51% in x direction, while 54.43 in y direction. Similarly, we can see 63.49% in x direction, while around 20% in y direction. It means that it is having a mixed type of mode. Generally, we have to translate in first two modes and have rotation in third mode. But in this building, we have mixed type of participation. Also, we can see story max over average displacement, and I will filter it. Now I will extract to Excel. Okay, it is extracted, and now let's say I will keep filter. Okay, from here I will check uh, and I will check only those whose value is greater than 3. Okay, from here we can see that the maximum to average ratio is greater than 1.2. Why have I taken maximum to average ratio is greater than 1.2, but we have minimum to max ratio, so we can generate average means mean ratio. So if we try to generate a minimum ratio, For minimum, I can simply average into 2 times minus maximum. We can generate minimum displacement, while we can create a ratio as well of max to minimum and create that these all the values have ratio greater than 1.5. So torsional irregularity exists. We can determine that the torsional building has torsional irregularity, and these all are in y direction. So we have to check in which direction is the building, or we in which direction shall we increase stiffness. From here, let's say I am taking y direction, and similarly in 1 and 2 direction the torsional irregularity is existing. So I will check in mode 1 and apply, and we can see here in this direction there is 7.476 mm in the extreme A or say A grid, while in grid E the extreme point has 11.59. So it is simply calculating that 11.597 time divided by 7.7.476 equal to, yes, it is 1.55. So either we should make grid A or this corner to translate more within permissible limit, or we shall make grid E or this DE line such that the displacement should be lesser, or the ratio of displacement in this corner, maximum displacement to minimum displacement, should be less than 1.5. So I am going to increase the moment of inertia along grid E in y direction. Okay, now I am unlocking the model. Okay, now I will select all story and assign at first a rectangular column such that it has greater dimension or greater moment of inertia along y direction. Since it is y direction, so I will make a higher moment of inertia along y direction. Therefore, I will go to section properties. I have already defined. Let's say I am taking column 400 by 600. Oh, sorry, I have to assign frame section frame 400 by 600. Okay, I will making first trial. If it is not oriented along y direction, then we can rotate local axis, but in this by default it has an it is oriented along 90 degree y direction, so it is okay. Then I will again run the program. Okay, then I go to display, or say we can directly check from here. Okay, we have problem in y direction, therefore I am going to check in y direction directly. Okay, at first it is 747. Initially it was 7.47. Okay, in this at this time the displacement in y direction is 11.519. Okay, initially it was 11.597. Okay, it didn't really help us. Therefore, I will again unlock the program and go to all story, and I will select this both column and assign a rectangular column. Okay, these are also oriented in the similar direction. Okay, I will run the analysis. Since it is a iterative process, we have to do an hit and trial for multiple times. Okay, I have aligned the column in the y direction in grid E. Okay, I'll go to, okay, we can go to here, y direction 1 mode 1. Okay, sorry, apply, sorry, we have to apply in this window. Okay, 11.013, initially it was 11.59. Okay, it is decreasing. Okay, 7.43, 7.43. Okay, then it is not working with this size of column. So again I will go to all story. I will select it again and assign a bigger size column. Let's say column 400 into 800. Okay, then I will again check. Okay, it is again analyzing. Okay, then I will again show tables. We can directly hit into the similar way. We can check from here as well. Okay, in this figure, okay, we can again export the data. So now I will copy all the data uh, and copy and paste in the, okay, I will again extract to the Excel. Okay, I have copied, extracted to the Excel, and I will generate a max to minimum ratio, minimum and ratio, and for minimum, average into 2 minus minimum, sorry, maximum, and we can generate ratio. Okay, then I will drag in the similar fashion, and I will apply filter as well, and check, do these have the ratio have better values. Okay, I think it is not actually working. Okay, I haven't copied the average value. I will also copy average value and paste here average value. Okay, now I will see. Okay, filter. Why it is not working? Sorry, I have to export that table. Okay, this has table. Okay, display, so table. I'm exporting this and then to Excel. Okay, for max to minimum ratio, minimum ratio. Okay, this times 2 minus max this upon this. Okay, now let's see, do any of these values have greater value than 1, 1.5? Yes, we can see that in this y direction in 2, in mode 2, then we have values greater than 1.5. It means that there is torsional irregularity. Okay, then we can sort out problem. Okay, this is size 400 by 800 is also not working. Then we can try by placing a shear wall. At first I will make that these all are 500 by 500 column. Then I will define a shear wall. Okay, for that shear wall I have to go, sorry, I have put for shear wall. Okay, we know that the system shear wall that are part of lateral force resisting system, the minimum thickness of special shear wall shall not be less than 150 or 300 mm. Okay, and I will take 300 mm, and minimum ratio of length of the wall to its thickness shall be 4. Okay, we have to define width to thickness ratio is greater than 4. Then I will go to shear wall, and okay, I have, since my beam is 350 width and 550 depth, so I have to define at least of 400. Okay, 400. Okay, everything is okay. Okay, then I will go to elevation E. Elevation E. For 400, 4 into 4 times 400 into 4 times is 1.6 meter. Okay, I will place the shear wall in center and I will remove the column. Okay, then I have to replicate. Okay, for replicate I will replicate in y direction 0.8 meter in y direction, and similarly minus 0.8. Okay, then I will draw, select a shear wall of 400 mm thickness. I have selected all the storage, and I will assign, and I will delete the rest of columns. Okay, I will assign a fix. Okay, we can check rest of part. Today I am telling how can we remove torsional irregularity. So I will not design a structural member. However, I will include how to check and remove the torsional irregularity. Okay, then it is analyzed. Now go to tables. Then okay, this time the mass is also participating in first mode it is translating, and similarly in second mode it is also translating, and in third mode it is translating in, sorry, it is rotating. So it is okay, but our major concern is to check whether it is torsional irregularity or not. So I will check maximum to average is there any ratio greater than 3, then we can check filter greater than 1.2. If okay, then again it has a problem. Okay, the ratio is increasing. Okay, let's check plan. Go to plan first. Now we can also check in similar fashion. Now in this side the displacement is 3.52, while in this direction there is 7.376. It means that this this shear wall has made the building stiffer in y direction in extreme corner or in say grid E. Therefore, we can either we have to make stiffer in this direction or we have to decrease the size of shear wall or width of shear wall. So I will again uncheck this and I will find a suitable location. Since it is a hit and trial method, I can try where it will definitely help, I think. Since it will not, there is toilet, so it will not disturb our architectural requirement. As we know that it is hit and trial method, so our major concern is to increase moment of inertia in the lateral direction in which the maximum to minimum ratio of displacement is greater than 1.5. So at initially we have maximum displacement in grid E, but now I have made the I have kept serval in grid E and made it stiffer. Now this time the grid A has maximum displacement while E has minimum displacement. It is acting as an inverse. So I will decrease the size or place a shear wall such that it has the ratio is within the permissible limit. Okay, at first I will delete this shear wall, or we can go to elevation. I will delete this. Okay, I will keep assign a column of 400 by let's say 800 in this direction. Also I will keep a column in this direction as well. If it will work, then we can modify in similar fashion. Okay, this time this column is rotating in y direction which will not help in our case, so I will rotate its local axis. Okay, assign frame 6 sorry local axis 90 degree. Okay, apply. Okay, now this column has a moment of inertia higher side in y direction, so I will again run and check whether it will help or not. Okay, okay, I have analyzed. Now I will again check whether it is helping or not. Okay, this time this has 6.96 and 10.539. Again it is not working. It means that it has maximum displacement 10.539 10.539 upon 6.96 1.51. It is also greater. Then let's make this as rectangle and this as rectangle. I think this will surely help. Let's assign 400 by 600. Then again rerun the analysis. Okay, display. Now again I'm checking. Okay, I think the problem will not be solved so easily since it has mixed type of mass participation. Okay, let's us check this in whether it is working or not. Okay, it the problem is as it is. So I think I have to define a column. It will in this grid, then it will be easier. Okay, then I will assign all the column as a square one, and in this corner I will assign a shear wall. Okay, then I will delete this column and sorry, grid E. I will assign a shear wall 400. Okay, straight. Okay, now I will again run. I have in this time I haven't measured the size what I have provided, but I'm trying to just to demonstrate how to remove a torsion from a building. Okay, the building is analyzed. Now I will choose display, show tables, go to the similar way. Now this time it is translating. So I think this time the problem is solved now. Okay, ratio greater than 1.2, apply. Okay, this time there is no any torsional irregularity. Besides these, okay, we can check here from here as well. Go to QY. Since there was a problem in Y direction, 7.44 upon 6.33. The ratio of 7 to 6 is less than 1.5. Okay, check in mode 2 as well. 6.55 upon 7. Okay, this is also in permissible limit in mode 3, 5, 8. Okay, we can check in. Let's check 8.35, 8.335 upon 5.73, 5.732. Okay, it is within permissible limit. Okay, in this way we can remove torsional irregularity. The beam is removed. I think I have deleted. Okay, I will resolve this problem, but in this way we can encounter the torsional irregularity. Also we can check CM and CR, which is center of mass and center of rigidity. We can export table. Okay, I have exported this. And for static eccentricity, static ESI, ESI in X, similarly ESI in Y direction. Okay, ABSO absolute of X minus R. This is in meter, while ABS CM minus CR in y direction. Okay, now let's check for eccentricity. For eccentricity, length in x direction while length in y direction. Okay, we can check from drawing that we have tentatively of length in x direction is 50 feet, and for conservative side we can take length of the least value, but for easiness or demonstration purpose I have taken the maximum dimension. Okay, maximum dimension in y direction is 42.5 feet. It means that 42.42 upon 3.28. Okay, 12.93 meter is length, while in 50 upon 3.28. Okay, 15.24 meter. Now okay, for eccentricity ECE in x direction should be uh, eccentricity in x direction upon length in x direction. Okay, 60.74%, while in ECE in y direction should be ESI upon LY. And from this data, it is seen that eccentricity in y direction is less than 10% in y direction, so it is okay. However, we have to, in this case, in first diaphragm, the eccentricity in x direction in first diaphragm 16.7%. It means that it is exceeding than 10% as our caudal provision. So we have to place the CG in x direction such that it is less than 10%. Okay, center of mass is in 7 degree, where center of rigidity initially, let's say it is 7%, it is 7 meter from x direction, but due to the presence of shear wall, the center of rigidity has shifted 9.55 meter from this origin direction. So let's say it is locating in this side. Now I have to decrease the center of rigidity such that the CR moves or comes nearer to center of mass. Okay, this is for this session. Now we will meet in the next video for the detailed design and how can we uh, make an eccentricity within permissible limit in the next video. Thank you.